Hey, it's Mr. Allred, and we're solving systems of equations. We just went through the substitution method and some examples, and here we are at our second method, which is elimination. So let me see if I can explain this. Elimination is going to try and get rid of one variable so that we have an equation with just a single variable. It does a little bit different than substitution. So set up here is we got to line the equations up on top of each other. And we got to do this so that all variables and equal signs are lined up. So what I mean by that, if we go back to the original example I had, which was the two linear equations, y equals 2x plus 1 and y equals negative 3x plus 6. If you notice here, the equal sign, the y and the x's are on top of each other. They're in the same order. So we want to line those up so they look like similar equations. Then the tricky part here is we're going to multiply one or both equations by a value that makes the coefficient of one variable the same with different signs. So let's kind of put that with step 3. Then we're going to add the two equations together to cause one of the variables to cancel out. So let me show you what I mean there briefly. So back with the two lines. If we take the y equals 2x plus 1, the y equals negative 3x plus 6, and say we just wanted to put them like this and we wanted to draw a line under them and say plus, 1y plus 1y would be 2y. Okay? But if we had a negative y and a positive y, they would cancel out. And if that happened, then we'd only have x's in what we combine it to be. So we're going to try and get coefficients in front of one of the variable. It could be y or it could be x, so that when we add them together they cancel out. So they need to be the same coefficient but with different signs. So let's see here. After we add them together, there will only be one variable. We'll solve for that variable, and then we got to plug it in and solve for the other variable. Okay, so keep these close by. Let's go to an example. The example is going to be two equations, x plus 5y equals 15. And the other equation is 2x minus 3y equals 4. So this one already has everything lined up on top of each other, so step 1 is done. So step 2, we're going to try and get either for x or y like coefficients with different signs. And the thing here is, if we were to look at y, 5 and negative 3, if we want to multiply by something to get those the same, they're not really multiples of each other, so we'd have to multiply both of them. But because there's a 1 in front of the x, we could multiply the x by anything we wanted to and turn it into anything. So the other x is positive 2, so we want this one to be negative 2. So we're going to take the first equation and we're going to multiply it by negative 2. So there we'll have negative 2 times the equation of x plus 5y equals 15. And we'll distribute that through, be negative 2x minus 10y equals negative 30. So there we have multiplied and we made it the same. So multiply by negative 2. But we're going to bring the other equation down to put with it. So we're going to write under it with everything lined up, 2x minus 3y equals 4. So in that case, we're going to line everything up, and we're going to take these two, and we're going to add them together. So in that case, the x's will cancel out, negative 2x plus 2x. The y's will give me negative 13y, and on the other side it'll be equals negative 26. So I've got one equation with one unknown. So then we need to solve for that unknown. So we're going to solve negative 13y equals negative 26 for y. So we'll divide both sides by negative 13, and we'll get y equals 2. So we got one of the variables. So let's solve for the other one. So now we're going to let y equals 2 and solve for x. And it doesn't matter which equation. Let's just take the first one since the x is singular. So we'll have x plus 5 times 2 equals 15. So there, y was 2. We're just going to solve for it. So I get x plus 10 equals 15. So subtract 10 from both sides, so I'll have x equals 5. So the solution to this system would be x equals 5, y equals 2. You could come back to the original set of equations, plug it in, and solve. Okay. Make sure it works. You could check it. Okay. So let's go to another example. This one is I'm solving the same problems I saw before, just with a different method. So this one was 4y equals 20x minus 44, and the other equation was 3y plus 2x equals 18. And it really doesn't matter where I put these things as long as they're lined up. But in the beginning, they're not lined up because in the first one, the x and y are on different sides, and the second one, the x and y are on the same side. So since it doesn't matter, I'm going to bring the x term over in the first one. So it'll be 4y minus 20x equals negative 44 over 3y plus 2x equals 18. So now I have y over y, x over x, and equals over equals. So everything's lined up. But the problem is, if I add these together, I would get 7y minus 18x equals, I don't know, but not, the x and the y is still there. So if you think about this for a little bit, what you could do is you could try and get the y's the same. But since 4 and 3 don't have a common multiple or common factor, you would have to multiply them both by something. So you'd probably have to multiply the top one by 3 and the bottom one by 4, make one of them negative, so that one would be 12, one would be negative 12. But what I would do is I would take the second one, and since negative 20 is a multiple of 2, I would multiply the second one by 10. So I'll multiply 3y plus 2x equals 18 by 10. So if I do that, I'll have 30y plus 20x equals 180. So let's take that, or let's take the original, which was, or the first equation, 4y minus 20x equals negative 44. And we'll put that over what we just found, the 30y plus 20x equals 180, and we'll add them up. And we can see that the x's are going to cancel out, but we'll have 34y. I don't have a calculator right here, and I can probably do it in my head, but let's make sure we get it right. 180 minus 44. 136. So 34y equals 136. We'll divide both sides by 34. So now we're actually solving here. So we'll have y equals, I'm pretty sure that's going to be 4. Yes, y equals 4. So I've got one number. And then step 5, I'm going to solve for x by using that y equals 4. So let's take the first one, why not, 4y. So we'll take 4 times 4 equals 20x minus 44. So in cleaning that up, let's see here. We'll have 16 equals 20x minus 44. We'll add 44 to both sides. We'll have 60 equals 20x, and then we divide both sides by 20, we'll have, I don't know what happened there. Let's see if we can clean it up a little bit. We'll have 60 equals 20x, and we divide both sides by 20. That'll be x equals 3. So the solution to this system is x equals 3, y equals 4. Now I just kind of realized when I made this, I did it on purpose when I made it, but I forgot while I was doing the problems. When I did the substitution method, I solved the same thing. So here for elimination, I got x equals 3, y equals 4. Up here with the substitution method, I did it differently, but I got the same answers. And then with the first example I did with both, I got x equals 5 and y equals 2. Yes, I got that for the substitution and the elimination method. So it doesn't matter which method you use. Sometimes one method is a lot quicker and a lot easier, or if a variable is already by itself, it makes your life a lot easier to use one method versus the other, depending on what your numbers might be. Alright, so there we go with that. We'll look at some strange outcomes here in a moment. Thank you.